Let's talk about the relationships between the graphs of f and f prime. No new vocabulary here, no new theorems or rules. So we start like this. When we have the explicit formula for f of x, in other words, if we have f of x is equal to x cubed, or f of x is equal to square root of x, we can derive that formula for f prime of x using methods like we did in examples 1 and 2. So we're talking about the definition of derivative and the alternative definition of derivative. But we've already seen that functions are not always encountered that way. We see functions as strictly graphs, or we see functions as tables of data. So how would we get a formula or at least see the derivative if we didn't have an explicit formula? Well, it has to do with the fact that we can think of derivatives as a point in graphical terms as essentially the slope. So we can get a good idea of what the graph of a function f prime looks like by simply estimating the slopes at various points along the graph of f. So here's an example where we're going to try to do that. Let's try graphing the derivative of a function f down below, whose graph is shown here, and we want to discuss the behavior of f in terms of the signs and values of f prime. So first, let's give ourselves an xy coordinate plane that tries to mimic what we have in the graph to the left. So we're going to label the x-axis 1, 2, 3, 4, 5, 6, 7. And let's label the y-axis up to 5. So 3, 4, 5. This is the y-axis. All right. So we see here points labeled A, B, C, D, E, and F. And what we want to do at each of those points is estimate a slope. And we can see that's been done for us at point A. There is a line drawn in that looks to be tangent to the curve at point A, and we see that the slope there is 4. So for the graph of f prime, we would want to go 0. That's where point A is located on the x-axis. But instead of plotting the point where A is, we're going to plot the slope. That's what a derivative is. So 0, 4. And one issue I see here is this isn't y anymore. It's actually y prime. All right, let's move on to point B. So we're going to think about a tangent line at B, and we see the slope of that tangent line there is 1. So at 1 on the x-axis, we're going to go on our graph of y prime and plot the slope at point B, which is 1. And then we move over to point C, which is located at x equals 2. We think about a tangent line there, and its slope we see is 0. So we go to point 2 and plot 0. And then we continue on through point D, E, and F. So at point D, which is at x equals 3, we think about our tangent line, and that slope is going to be -1. So we go 3 and we plot a -1. So that's about right in here. I can even go down and label the graph -1. All right, next up, we move over to point E. And point E is all the way over at 5, and we see that it also has a tangent slope of -1. So the derivative at 5 is also -1. And then at 6, we see a slope now of the tangent line being 0. So we're here. And the way to finish off the derivative then is to graph a continuous curve that connects these points. And so we might do something like this. And so even though we don't have an explicit formula for this graph, we do have a way to visualize its derivative and think about the relationship between the derivative and the function. The next slide, we're going to see how we did. So I put the answer in, and hey, not so bad. Let's look again. There was our graph. Here's the correct answer. This is y equals f prime of x, and not so bad. So the next part of this question is to discuss the behavior of f in terms of the signs and values of f prime. So I want you to notice something here. Look how the graph of f is increasing, going up all the way until we get to point C. And notice that in correspondence on the graph of f prime, this function, even though it's decreasing, it's all above the x-axis. So f prime is positive. Now watch, the graph of f is decreasing, going downward from point C all the way until point F. And notice that in point C to F over here, the graph of f prime is below the x-axis, so we would see f prime negative. All right, to finish it off, we increase again after point F on the derivative. F prime is positive. How about that? So let's move on and try another. We want to sketch the graph of a function f that has the following properties. Property 1, we want f of 0 to be 0. So our graph needs to contain the point 0, 0. 2, we want the graph of f prime, the derivative of f, to be exactly as we see below. And f is continuous for all x. So we're going the other way now. We're given the derivative f prime. We want to graph f. So in other words, what function f has this graph as a derivative? This is f prime. So let's get ourselves a nice xy coordinate grid. And let's label it a little bit to here's 4, -2, -4, 2, 3, and how about -2, 3? All right. So what do we notice about the derivative? The derivative seems to be -1 at all points up until, well, x equals 1. So if the derivative is the value -1, that means f has a slope of -1 at all of these points. Okay, so I think we can actually start to graph a little bit. Recall that f of 0 is 0, so we definitely want this point here. And all the way until x is equal to 1, the slope of f is -1. So all I'm going to do then is plot a graph with a slope of -1 all the way until I get to x equals 1. So what happens after x equals 1? Well, we jump up here. Here's a jump discontinuity, and we move to a value of 2. And it looks like the value of 2 is constant all the way through from x equals 1 on to the right. And we don't know if this graph stops ever. It might go on to infinity, but at least in the portion of the graph we can see the slope of f is 2. That's what we mean. If the derivative here has a value of 2, the slope of f has a value of 2. So that means after x equals 1, I now need to sketch in a line that has a slope of 2, or at least a curve that has a slope of 2. And also keep in mind, number 3 here, f is continuous. So I don't need to move my line any other place. We can pick up right where we left off. And this time we're going to go a little bit steeper with a slope of 2. And so here is a graph of y equals f of x. I'm going to label it f here where this one was f prime. And what we did was move in the other direction and take a graph of f prime and turn it into a graph of f.